uh, um, at the Ateneo de Manila University in the Philippines. Dr. Salmo is a restoration ecologist that tracks the recovery of biodiversity and ecosystem functionality of restored mangrove stands of different ages and compares it with the natural mangrove stands. His work ranges from vegetation to sediment and macrofaunal biodiversity to generate parameters that serve as restoration indicators. Dr. Salmo will be presenting on blue carbon ecosystems, conservation and policy needs for effective climate change adaptation and mitigation strategies. Oh, okay, all right.
Thank you. just to make sure. And then this one. Sorry. Nah, yeah, the other side. Thank you. Yeah. Full screen. Okay. All right. Thank you. All right, good morning. Throughout this conference, we've heard about discussions on the concepts, processes, and impacts of...
Reverse your scan. There you go.
Thank you. So the last 4 days have been about discussions on the concepts, principles, processes, and the impacts of climate change. For this talk, however, allow me to present a work on adaptation and mitigation strategy. And I'm referring to the blue carbon ecosystems. I will be presenting concepts on blue carbon and the emerging field on blue carbon science. How are we using blue carbon science as a management and conservation tool? Our current progress and the challenges that we experienced in the last 10 years so far, and a summary of our lessons. We are all familiar with these images. There is a global recognition of the global increases in temperature and increases in CO2 emission. In fact, in the Paris Accord, there's a consensus that we really need to meet this 2 degrees Celsius target. Otherwise, there will be consequences on the global warming and impacts of sea level rise. Our group, however, is proposing that blue carbon coastal ecosystems are a viable solution to address this challenge. When we talk about blue carbon, 2 critical concepts is that the carbon that is stored and sequestered for a long time. These are in coastal ecosystems, and it's very definite. It is found in mangrove forests, seagrass meadows, and intertidal salt marshes. The map shows the global distribution of blue carbon ecosystems. Please note that these blue carbon ecosystems are more apparent in tropical developing countries, wherein you experience several anthropogenic and natural disturbances. These blue carbon ecosystems are very important. More than or around 83% of the global carbon are moving through the ocean. Although these coastal habitats only occupy around 2% of the ocean, around 50% of the global carbon could be found in the oceanic sediments. So really very effective in doing this mitigation strategy. When you discuss these blue carbon ecosystems, these carbons are found in the above ground and the below ground components of the plant biomass and also in the sediments. Right. This initial work shows a simple process of the sequestration process. Through the process of photosynthesis, CO2 are absorbed from the atmosphere, and those CO2 are deposited as carbon in plant biomass, and in turn contributes in the plant growth. Okay, here you have your mangroves, salt marsh, and that of seagrass meadows. And true enough, Here are the some of the estimates of the rates of carbon sequestration of mangroves, tidal marshes, and seagrasses. And these are the estimates of global extent of these ecosystems. You get this idea of the sequestration rate and the total extent of these ecosystems. There will be a good contribution of carbon sequestration out of these ecosystems. However, when damaged or disturbed, these ecosystems will actually result to high CO2 emission. And these are the values that were found from that study. Another important insight is that the performance, in the case of mangroves, for example, the performance of sequestering carbon is also affected by the tidal position. For example, mangroves that are located near the shoreline or in coastal fringes are regularly subjected into tidal currents, wave actions, etc. And therefore, very regularly, they are affected with the carbon losses. In contrast, mangroves that are located in upper intertidal position are the ones that have more stable position, and therefore, the carbons that are stored in higher elevation are the ones that are relatively more stable. This concept is very important, especially in the light of assessing the vulnerability of carbon sequestration, especially if these ecosystems will be subjected into occurrences of typhoons, or you call it hurricanes here, and that of a rising sea level. Right. Again, on mangroves, it is known as an ecosystem that has high carbon stock and therefore limits CO2 reduction. The most stocks are stored in the sediments, and mangrove sediments have very low oxygen. And if you have low oxygen, the carbon that is supposedly be released through respiration will be easily trapped and deposited in several depths, in several meter deep of the forest. And because of the continuous litter production, this litter production will be degraded as part of the detritus. And because of the structural complexity of this ecosystem, the litter production is actually the one that is contributing to organic matter and organic carbon deposition. And by doing so, mangroves is not just contributing in CO2 reduction, but also because of the continuous accumulation of this organic detritus, it also helps in increasing the surface elevation. And again, this is very important in assessing the contribution of mangroves in compensating the impacts of a rising sea level. In 2011, the group of Dr. Donato came up with a report on the contribution of mangroves in sequestering carbon. And they found out that more than 60% of carbon stocks are actually found in the soil. This study actually came up with the conclusion that mangrove forest has 4 to 5 times higher rate of carbon sequestration as compared to any type of forest. This work actually started the intensified research on blue carbon. Our Indonesian counterparts came further and came up with this assessment of the contribution or the potential of Indonesian mangrove forests and also that of seagrass meadows. If healthy, these ecosystems will really contribute in sequestering atmospheric CO2 and depositing it in the plant biomass. Right. When you talk about mitigation, another feature of these blue carbon ecosystems is the adaptation. And true enough, there are several known adaptation benefits if we will manage these blue carbon ecosystems. Well, first and foremost, you have your biodiversity conservation. These ecosystems are very good in coastal protection, wave attenuation. We establish the sediments. That's the technical side. But the other contributions are the increase in food and fisheries resources, even that of tourism, and providing livelihood to coastal residents. So, we know the values of managing and conserving these blue carbon ecosystems. In the Philippines, where I came from, there is also a need to practice mangrove restoration. And this is not just exclusive in the Philippines, but in fact, it's happening in Southeast Asia, or practically the entire Asia-Pacific region since late 1980s. So the red line demarcates the mean intertidal level. If you know your ecology, the ideal restoration site should be higher than the mean tidal level, so this spot. Anything that falls below that is below the intertidal level and therefore not ideal for restoration program. Its individual white picture here corresponds to one single individual. They planted mangroves all the way to here. And in the Philippines, there have been a good documentation saying 80% of these restoration programs are complete failure. Meaning, those mangroves can rarely last for 2 years, and assuming they last for 2 years, the growth is really stunted. Now, these are not a good lesson to start with, but we can learn a lot from these restoration programs. In fact, there's this adaptive restoration program that we are realizing now. We follow the correct species, the correct plantation site, and what we call this adaptive restoration. Mangrove restoration program or a mangrove planting program should be relatively easy if you do it right. And in fact, assuming you're following a good restoration program, there's a good documentation from our study that in 15 to 25 years' time, your mangrove plantation can actually match the vegetation structure of a reference intact mangrove forest. Right. A classic example is the program of Conservation International Philippines. Mindoro is one of the recognized global biodiversity hotspot. In this program, CI Philippines is promoting a green wall concept, or practically a green belt. They just don't go with patches of mangrove conservation program, but actually it runs several kilometer stretch of this global biodiversity hotspot. Definitely, CI Philippines have learned a lot from the massive restoration program, and therefore they are quite adaptive with those lessons. Now, we know that the need for blue carbon ecosystems, and we know the need to restore these blue carbon ecosystems, but these ecosystems, although you're conserving or restoring it, are still heavily subjected to several forms of disturbances. Among these are your unsustainable aquaculture, coastal development, food agricultural practices, and even that of pollution, not to mention massive mining industries. Okay, in the Philippines, we have this, what we call the last ecological frontier, but one of the challenges in tropical developing countries like ours is that there's this massive movements of communities in coastal areas, a simple concept of human migration. When people settle in one area, the closest ecosystem that is accessible is mangrove forest. So when the community settles in, they cut forests, and over time, they need to sustain their livelihood, and there will be obviously a land use change, and after that, when the opportunity opens up, some of this will be used as aquaculture ponds. Now, I'm citing studies here by Dr. Kaufman and also one of our studies here in Palawan. When mangroves are converted into an aquaculture, it results to around 60 to 80% loss of total carbon stocks, which is quite similar in the Philippines. These are the small-scale aquaculture ponds, but in Brazil, in a commercial aquaculture, just the same. It's around more than 70% of your carbon-rich soil are actually lost. Okay? More on fish ponds. The red dots here are the distribution of aquaculture fish ponds in the Philippines. And we came up with these studies just last year that these fish ponds are actually emitting 2.6 times higher CO2 emission. Now, when you operate fish ponds, the first step is actually you kill the vegetation that are present in that. So it's a complete wipe out of the vegetation. But aside from that, there is a 1 meter excavation of the sediments. So the carbon that has been stored and sequestered for hundreds or thousands of years, when you excavate it, you release it outright. But we're not just talking about CO2 here. There are other greenhouse gases that are continuously emitted, most notably methane and that of N2O. So here, there are around 245,000 hectares fish ponds in the Philippines. There are more in Indonesia and that of Thailand and some portions of Malaysia. Failure to restore these fish ponds or a further delay of restoring these fish ponds into mangroves will continuously emit greenhouse gases. But we've been talking about anthropogenic disturbances, but these blue carbon ecosystems are also subjected to natural disturbances, and I will mention one in Western Australia. There is this marine heat wave that happened sometime between 2011 to 2012. The site is recognized as the site with the world's largest seagrass carbon stocks. In one single event, there was this 36% damage in seagrass meadows. What does that translate to? The carbon stock that has been stored in these seagrass meadows after this marine heat wave event resulted to the release of around 2 to 9 teragrams of CO2. Coming up with the numbers, this is translate into 4 to 21% per year of CO2 emission for the country, for Australia. Now, this is seagrass. While people are talking about coral bleaching in the Great Barrier Reef, almost at the same time, there was this massive mangrove dieback in Northern Territory, also in Australia. The lead author is my PhD supervisor, Dr. Norman Duke. And in 2015 to 2016, that somewhat coincided with the bleaching event in GBR. It resulted to around 1,000 kilometer stretch of affected mangrove dieback. How much does it cost? It's around 7,400 hectares of massive mangrove mortalities. Now, the authors cannot pinpoint one single parameter that really caused the massive dieback. What they know and what they're saying is that there is high temperature, low precipitation, and severe drought for a long time, and that really resulted to massive mangrove dieback. Now, we know the values of the blue carbon ecosystem in terms of carbon sequestration and the reduction of CO2 emission. We know the values of the need for conserving these ecosystems and the need for restoring these ecosystems. We also know that there are anthropogenic and several natural disturbances. How do we turn this knowledge or this information into conservation projects? There's this Blue Carbon Initiative that was formed around 10 years ago. And it is currently facilitated by Conservation International, UNESCO, and that of IUCN. There are two groups within that initiative. One is the Scientific Working Group, which is in charge with the accounting of carbon stock and CO2 emission. These are your technical experts. And they formulated an international standardized method in assessing carbon stock or the CO2 emission. These technical information are translated into policy, and they work together with the policy working group. The policy working group advocated for some inclusions of the blue carbon ecosystems. I think, in my opinion, one of the most notable contribution of the initiative is the lobbying for the inclusion of blue carbon ecosystems in the IPCC reports on national greenhouse gas inventories. Over some, very recently, this initiative has been picked up by several agencies. For example, the International Partnership for Blue Carbon, the Ocean and Climate Alliance Initiative, and I think very close to my place is the Coral Triangle Initiative. Initially, the focus is on coral reefs and fisheries, but now they are now integrating the blue carbon ecosystems as part of their program in the CTI project. Okay. Moving along, if you know those blue carbon ecosystems and you have those values, then we are in a position to convert into this technical knowledge into developing market-based projects, for example, carbon credits, and I'll be referring to some of the contribution of the blue carbon ecosystems as a driver for policy formulation. One of which is the NDCs that were discussed during COP meetings, some voluntary markets involving the government and the private sector, and that of the payment for ecosystem services, and I'm referring to the RED Plus program. But before you do that, you can do that, there is a need for countries and regions first to recognize the value of carbon in these ecosystems. At least in the Philippines, there are some corporate partners or industry partners that adopted blue carbon ecosystem as part of their corporate social responsibility. This is a good start, in my opinion, and I hope this will be spread in the region as well. Okay, talking about the NDCs, at the moment there are 28 countries who adopted blue carbon service as part of their mitigation programs, and only 59 countries use blue carbon in their adaptation programs in the NDCs. Numbers are quite low, and the main problem here is that there are several countries yet that are still not able to account for their blue carbon ecosystem, or not able to account for the carbon stocks in their respective countries. A very important point here is that over time, there will be a good realization that there are some countries that can use both mitigation and adaptation programs as part of their NDCs. And it's a matter of time, in my opinion. Right. We discussed about values of carbon stocks, CO2 emissions. We discussed about the need for conservation and restoration. We also know that they are subjected to several natural and anthropogenic disturbances. But we need to act now. We know that it's a natural solution to climate change. Perhaps it's a natural solution to climate change, but there are still some issues. First and foremost is the need to know the rates of carbon gains or losses, referring to the fluxes. There's still a need for a better methods on assessment and mapping, or account for the emissions, or come up with a more systematic monitoring of these blue carbon values. There's also a need to study the effects of disturbances on blue carbon ecosystems, most notably the occurrences of typhoons and that of the rising sea level. And this information should forge a linkage between scientific community and that of the policy groups. Image on the left is the occurrences of typhoons. You call it hurricanes here. I know you're mentioning about Hurricane Katrina, but I came from a country where we had if you're familiar with the Super Typhoon Haiyan, which in record is the strongest typhoon that hits in modern meteorological history. That resulted to around 20% damage of Philippine mangroves. And it's just a single event, but we do receive 20 typhoons in a year. When there's a typhoon, obviously the immediate impact would be the loss in vegetation. But during typhoon, I don't know if you have storm surges here, but during Super Typhoon Haiyan, there is a 1 meter storm surge, around 7 meter wave, but also it practically scraped around 1 meter of sediments. These are your carbon-rich sediments, right? Typhoons is a problem, and we have 20 typhoons in a year. It forms a deadly combination with that of a rising sea level, right? And Philippines and Indonesia, for example, we do have 4 to 5 times higher rate of sea level rise as compared to international mean values. The occurrences and the frequency of occurrences of typhoons and sea level rise somehow will have a negative effect on the resiliency of these systems in the long run. In summary, our group proposes and argued that blue carbon ecosystem, or blue carbon as an ecosystem service, is a viable climate change mitigation and adaptation strategy. It's practically most countries have either 1 or 2 ecosystems. It could be seagrass, mangroves, or tidal salt marsh. It's just a matter of time that we need to know how much carbon is stored in these systems and how much CO2 are being reduced for emission. But we also recognize that there is a need to have a more systematic assessment and monitoring methods. And with this knowledge, if information will be updated in the next coming periods, then we will be in a position to incorporate and refine blue carbon as part of the NDCs and other international frameworks, for example, the RED Plus program. And lastly, there is a need to develop innovative financial conservation practices or the sustainable financing mechanisms that will benefit the local communities. And I thank the organizer for inviting me here, and of course the Conservation International, IUCN, and UNESCO. Thank you very much.
We have some time for questions. Are there any questions? Please come to the microphones.
Yeah, thank you very much for this very, very interesting, exciting presentation about blue carbon. Sorry. My question is, how are there strategies to develop accounting methods, since there's maybe double counting or missing if you have extreme events like typhoons, hurricanes, storm surges. There may be side effects due to nutrients, so nutrients may be used in a different place and not be available downstream. Are there developments that are encouraging to develop proper, solid accounting ways?
Right. Thank you for that very interesting question. I'm not in a position to give you a comprehensive answer, but what I know is that it's site-specific, and it will also depend on the baseline data that you have. What I know is that, at least in the Philippines, there's through the World Bank program, there's this, I forgot the acronym, the meaning of the acronym. They call it WAVES program. They really accounted for the contribution of, I think it's just the mangroves that they incorporated with their values. I can give you the values if you want to. But yes, we do have some limited reports. It's not really that exhausted yet, and it's because of the limited data. But that's a good start, in my opinion. Thank you.
Are there any more questions? Robin.
Thank you for your presentation. In earlier presentations, we saw that much of the increase of food coming from the oceans has come from aquaculture.
Yeah.
You talked about inappropriate conversion of coastal wetlands for aquaculture. Are we headed for a big fight here between these two things, or is there a space for producing food that doesn't compromise these ecosystems?
Yeah, that's a good point, Robin. The fight happened 1960s or 70s, I think, if I remember correctly. I wasn't born yet at the time. But to answer that question, there's actually a good science on it. And the good science is that you need 1:3 ratio. 1 hectare of aquaculture should have 3 hectares of mangroves. And in that way, whatever pesticides or feeds you use from aquaculture will be mitigated by the adjacent mangrove areas. But that is 1:3. In my country, it's even less than 1:1. Yeah, there's a science.
Time? Okay. Thank you very much for your excellent. And I think it is very important to engage the people and understand, to make them understand about the ecosystems. But how can we implement or realize the payment for the ecosystem service? It's a big question for me.
That's also my question. All right. Again, I cannot answer for the rest of the Asia-Pacific countries, but at least in the Philippines, there's this practice of CSR of the big companies going to the rural areas, and of course the academia and Conservation International. They work together, and they explain this is the value of your coastal ecosystem. If you keep managing it, then there's this corresponding value. some companies are really providing funds to help maintain forests or maintain mangroves and seagrass. There are some initiatives. I agree, though, that it's not comprehensive yet, but I think we have a good start in that case.
Okay, well, thank you very much.
Thank you.
I have a gift for you. Thank you very much.
Thank you. Thank you. Thank you.